nice day to the audience.
Dr. Dayang.
And Dr. Rosita.
We are Group 11 ETH Production.
We are given a task on to produce 330 kg of 60% purity methanol per hour.
With the little guns come on, I wanna bust guns on the run when I come.
Hello, my name is Chong Yan Ding. My matrix number is 193245. Thank you.
Hello, my name is Rosmaina Adiba binti Nazri. My matric number is 193845.
Hello, my name is Zainab Malabakas and my matric number is 191567.
Hello guys, my name is Muhammad Subisan bin Muhammad Daros and my matrix number is 193551. Yes.
Hello, my name is Chong Yan Ding. Now let us introduce our process is methanol production from carbon dioxide, and our target is 330 kg methanol per hour. Our objective is to produce 60% purity methanol, and our method is by reaction between carbon dioxide and hydrogen gas. This can be shown by the equations. 1 mole of carbon dioxide react with 3 mole of hydrogen gas and produce methanol, and byproduct is the water. And the raw material we use is coal and water. Hello, my name is Chong Yan.
Hello guys, my name is Muhammad Subisan bin Muhammad Daros.
Now let us see the process description. The first step is the combustions, and then absorptions, stripping, electrolysis, mixing, methanol synthesis, and the last one is distillation. This is our process flow diagram, and with the table below. Now let us see the first unit is the combustion chamber, and as we can see that the temperature is 1340 degrees Celsius for the unit, and then the pressure is 0.001 atm, and the input is the coal and the oxygens. The ratios of oxygen to coal is 103.50%, and the output is free gas and the H. The ratios of the conversions of carbon dioxide is 95%. This means 95% of the carbon will convert to carbon dioxide, and the conversions of nitrogen dioxide is 27.60%. The function of the combustion chamber is to produce CO2, as we want the CO2 to react H2 to produce CH3OH, that is methanol. The stream flow produced is 40 degrees Celsius and 1 atm, and then the stream flow will enter absorber. The function of the absorber is to take out the carbon dioxide in the free gas, and as we can see, there are two input, which is free gas and the solvent. The solvent is MEF solvent, which contains 0.3 kmol MEF per kilomole and 0.7 kmol H2O per kilomole. And the carbon dioxide is absorbed by the MEF solvent and become the stream 7, and the other substance in the free gas will be removed out as treated gas. The temperature of the unit is 40 degrees Celsius and the pressure is 1 atm, and the efficiency of this unit is 0.9. Then the stream 7 will going into stripper. In the stripper, the temperature is 140 degrees Celsius and the pressure is 2 atm. The efficiency of removed CO2 is 1. This means all the CO2 in the solvent before enter the unit will be removed out as pure CO2. The function of this stripper is to take out the CO2 from the solvent, as we want to react CO2 with hydrogen gas to produce methanol. The temperature of the carbon dioxide produced is 40 degrees Celsius and the pressure is 148 atm.
In the electrolyzer, the hydrogen gas and H2 gas is produced. The system is operated at 80 Celsius and 1 atm. And the output for the oxygen gas is the 1687.64 kilogram per hour. The output for the oxygen gas temperature is 80 Celsius and 1 atm. The output temperature for the hydrogen gas is 80 Celsius and 1 atm also. The total in the mixer, there is no temperature or pressure because it's an open system, so no temperature and pressure. So the mixer is only mix the CO2 and H2 only. So the output for the mixture is 2164.53 kilogram per hour. The ratio is 0.25 kilomole CO2 and 0.75 kilomole of H2. And then the mixture will go into the methanol synthesis. In the methanol synthesis, the temperature is 220 Celsius and the pressure is 50 atm. The fractional coefficient for this reactor is 0.35. Hence, the mix when the and then the methanol and then the output methanol mass flow rate is 1136.377 kilogram per hour. And then the methanol synthesis, there still has impurities in the methanols. Hence, so we need to produce 60% methanol. So we go to the distillation column. In the distillation column, the crude methanol will go to the distillation column, and then it will separate the outwater gas such as CO2 and H2. The mass flow rate methanol we get is 330.004 kilogram per hour, and then the outwater gas is 806.373 kilogram per hour. The efficiency of the reactor of the distillation column is 0.99. Hence the 60% of purity of the methanol is produced. Thank you.
Hello, my name is Rosmaina Adiba binti Nazri.
So this is our process selection room. For coal, we need to burn, so we need combustion. The next one is absorption, stripping, electrolysis, mixing, methanol synthesis, and distillation. At distillation column, we produce the product that is methanol with purity of 60% methanol, 40% of water.
Dry.
So, for costing, the price of coal from reference is $140 per ton. Our total mass flow rate for coal is 15802.34 ton per year. So, as the calculated cost price of coal is $2212,420 per year. The price of methanol from reference that we get is $14078.28 per ton. The total mass flow rate of methanol that we produce from distillation column is 2890.8 ton per year. Then our selling price of methanol that we have calculated is 40697,500 per year. So for calculating the profit of company, this is the rough profit of company. So the selling price minus the cost price, then we get our profit company. Our profit company is 38485080 per year. Previously, the slide is the costing is in dollar, but we need to calculate it in Malaysia ringgit. So for converting the currency based on OANDA currency converter, $1 is equal to 4.08009 Malaysia ringgit. Price of coal in Malaysian ringgit is 157.21 per ton. Total mass flow rate for coal is still the same, 15802.34 ton per year. So the cost price of coal in Malaysian ringgit is 8173,128.27 per year. The price of methanol in Malaysian ringgit is 57440.6 per ton. Total mass flow rate of methanol produced is still the same, that is 2890.8 ton per year. Then our selling price of methanol in Malaysian ringgit is 165933654.5 per year. So for calculating our profit of company, as the same as the previous slide, is selling price minus the cost price. Then we get our profit company in Malaysia ringgit is 157760526.2 per year.
Hello, my name is Zainab Malabakas and
Okay, so based on the calculations and all, we have seen that our company will be able to produce 2,890.8 tons of methanol per year successfully by using a feed of 15,802.34 tons of coal per year. And based on the costings, we have calculated a profit of 157760526.2 Malaysian ringgit per year. And from our process, we have seen that a very small amount of methanol which is being produced can be sold at a very high price, so we will obtain a very high profit, and this can support the investment for the operating process. And so to conclude, our company has successfully been able to synthesize methanol from carbon dioxide. So here are a few recommendations for the process. Well, but when calculating our profit, we have not included the price of the equipment and the cost of the energy consumed. Hence, the costing is only an estimate. It's not an accurate profit for our company. And then the waste product which are being produced are being discarded, but we can use these products to make our process more cost effective. For example, the water being produced can be recycled to the electrolyzer, so that the cost of water will be less. And there are also some waste products which can be sold as other products which are in demand, so that the income generated will be greater, and then this can be used for other investments, for other projects.
예쁜 날 두고 가시나